Alright class, I am going to show you how to do a free response question for the AP exam for calculus. I was given Chapter 4, our group has Chapter 4, and this one specifically is about related rates, so I'm going to show you how to do it. Alright, a container has the shape of an open right circular cone as shown in the figure below. The height of the container is 10 centimeters and the diameter of the opening is 10 centimeters. Water in the container is evaporating so that its depth, h, is changing at the constant rate of -3/10 centimeters per hour. Alright, well first let's look at A. Find the volume of water in the container when h equals 5 centimeters. Indicate units of measure. Okay, I've already started a little bit. So, for A, we know that the volume of a cone is 1/3 pi r squared h. Okay, so it'll give you that on the AP exam. So we already know h equals 5. Okay, so now we have to find the radius. Okay, so the original radius is going to be 5 because half of 10 is 5, which is the radius, and the height is going to be 10 still. Okay, so we're going to go r over h equals 5, which is the radius, over 10, which is the height. Okay, so then we're going to solve for r, which we get r equals 1/2 h. And then we can go ahead and plug in the height, which is 5, okay, since it gave that to us. So we know that r equals 5/10, or 5/2. So now we can solve it. We can just plug everything in. So v equals 1/3 pi 5/2 squared times 5. Okay, so voila, all you have to do is solve it. And it is a calculator, like you can use your calculator. There's a calculator active part, so you could just plug it in to your calculator. Alright, sorry y'all, my freaking memory like messed up or something. But anyway, so you can just plug that in the calculator, work it out, but you will get 125 pi over 12 centimeters cubed. And you have to remember this because it says indicate units of measure. Okay, so now we'll get to B. Alright, find the rate of change of the volume of water in the container with respect to time when h equals 5. Indicate units of measure. Okay, so first we're going to start out by just putting the volume formula down. Okay, so for this is when we're going to have to find the derivative, and we're going to have to make this one variable. We can't have r and h. So we are just going to use h because we've already solved for r up here. Okay, so r just equals 1/2 h squared times h. You see what I just plugged it in. So now we're going to simplify this down. Okay, and simplify it some more. Okay, so we've simplified it pretty much all the way we can. Okay, so now we're going to take the derivative. Okay, so dv over dt equals, okay, so we're going to bring this 3 times this side by 3 and make this 2. So alright, sorry y'all, it freaking happened again, but anyways, so we did all this. Okay, so you see what I did there. I just took the derivative of that. Okay, So now we're going to have to plug in the values. So we know h is 5 and dh dt is -3/10 because, see, it gives us that right here. It says that its depth is changing at the constant rate of -3 centimeters per hour. Okay, so we know both of those values, and we're looking for this value. Okay, so so now we're just gonna simplify, or actually, you know what? You can just plug this in your calculator because it's calculator active again. So you will get -15 pi over 8 centimeters squared per hour. Okay, so that deals with B. Okay, just found the rate of change of the volume of water in the container with respect to time. There you go. That's how you do it. You just find the derivative. Okay, so C is really weird. Okay, so show that the rate of change of the volume of water in the container due to evaporation is directly proportional to the exposed surface area of the water. What is the constant of proportionality? Okay, so we haven't done a lot of this in class, but I looked it up, and so the area of the water to the exposed surface area of the water is just the circle right here. Okay, so don't let that confuse you. Alright, so you're trying to find the proportionality, so the equalness, I guess, of dV dt, which is the rate of change of the volume of water in the container due to evaporation. Trying to find if it's directly proportional to the exposed surface area of the water, which is pi r squared. Like that. Okay, so the weird part is that you have to put a k in. We haven't really done a lot of this in class, so it's kind of weird. So you're solving for k. Okay, so that's the proportionality of these two is k. So we're just going to plug in what dV dt is. Okay, so right here, so dV dt is like that. Okay, so it's equal to k times pi r squared. Okay, so that's going to be 25 pi over 4, because you just plug in the r value. Okay, so then we're going to bring it to the other side. We're going to bring this to the other side. Skip, flip, and multiply. Or bring this to this side. Okay, skip, flip, and multiply. So it's going to be -15 pi, over 8 times 4 over 25 pi. Okay. So when you plug that in the calculator, okay, these cancel out obviously. So you're left with -3/10. So that's the constant proportionality. Okay. So that's a little weird, but there you go. Alright, so now we are done with the problem, and that's how you do it. So yeah. Yeah, sweet.